In the Ellora Caves of India, walls built between 630 and 700 AD are still regulating temperature, 78 to 81 degrees inside, while the Maharashtra climate swings from 64 to 90 outside. The plaster contains 10% hemp fiber mixed with clay and lime. 1,500 years, still working. A Merovingian bridge in France from the 6th century used the same mixture in its mortar. 14 centuries of freeze-thaw cycles, still standing. In 2024, hempcrete was tested at 1,700 degrees Fahrenheit for 1 hour. The material did not burn, did not smoke, did not fail. Yet from 1970 until 2018, growing the primary ingredient in the United States was a federal crime. The Controlled Substances Act placed hemp, a plant with no psychoactive properties, on Schedule I alongside heroin. Farmers who wanted to grow it faced DEA registration, FBI background checks, and 24-hour monitored security fencing. The result, one legal hemp grower in America across 48 years of prohibition. 1. A wall that outlasts civilizations. A material that cannot burn. A plant that the federal government treated as a narcotic because no one could figure out how to meter the savings it creates. This is not a story about insulation. This is a story about what happens when a building material threatens an industry worth $10 billion a year. Welcome to Forbidden Manual. The archive opens in 2016 in the Ellora Caves of Maharashtra, India. Rajdev Singh, former superintending archaeological chemist of the Archaeological Survey of India, is standing inside Cave 12, a 3-story Buddhist monastery carved from solid basalt rock sometime between 630 and 700 AD. He has been analyzing samples of clay plaster from the interior walls. The analysis uses scanning electron microscopy, Fourier transform infrared spectroscopy, methods the monks who built this place could never have imagined. What Singh finds in the plaster changes our understanding of how long a wall can last. At least 10% of the material is cannabis sativa, hemp fibers mixed with clay and lime, applied to the cave walls nearly 1,500 years ago. Still intact, still functioning. Singh collects modern cannabis samples from Yalna and Delhi and runs them against the archaeological material. The result, in his words, a perfect match. But the discovery goes beyond chemistry. Singh measures the temperature inside the cave, 78 to 81 degrees Fahrenheit, stable. Outside, the Maharashtra climate swings from 64 to 90 degrees across the seasons. The walls are still regulating temperature, still performing the function they were designed for when the Byzantine Empire was at its height. They coded it out. They can't code out physics. Subscribe, the next archive opens soon. Now let's get back to the investigation. Estate, Milind M. Sardesai, botany professor at Dr. Babasaheb Ambedkar Marathwada University, interprets what this means for the monks who once lived here. As the hemp plaster has the ability to store heat, is fire resistant, and absorbs about 90% of airborne sound, he notes, a peaceful living environment for the monks has been created 15 centuries ago, still working. The nearby Ajanta caves provide a natural control group. They were built around the same era. They used conventional clay plaster. They did not add hemp. The decay is dramatically worse. Insect damage, structural degradation. The walls without hemp have aged. The walls with hemp have endured. Singh's conclusion is direct. Ellora has proved that only 10% of cannabis mixed with clay or lime in the plaster could last for over 1,500 years. Not a century, not 3 centuries, 1,500 years. The archive does not stop in India. At Saint-Cénary-le-Giré on the Sarthe River in France, stone bridge abutments from the Merovingian period, the 6th or 7th century AD, contain mortar with more than 10% hemp. The bridge still stands. 14 centuries of French winters, freeze-thaw cycles that crack ordinary mortar. The hemp fibers allowed the material to absorb and release moisture without fracturing. The physics is the same. The result is the same. The civilizations never met. Around 200 BCE, Chinese shipbuilders mixed hemp with lime and tung oil as caulk for their junk ships. A hemp house in Nagano Prefecture, Japan, built in 1698, still stands. Romans used hemp fiber to reinforce mortar across their empire, though the specific sites have been lost to archaeology. Not an experiment, not a prototype. Civilization. Before the Ellora findings, European researchers had estimated hempcrete wall lifespan at 600 to 800 years based on material chemistry and accelerated aging tests. The archaeological evidence doubled that timeline. The question is not whether hempcrete lasts. The question is why we stopped using it. The monks at Ellora did not have thermal imaging equipment. They did not have laboratory analysis. They did not have building codes or insurance requirements or appraisal guidelines. They understood something about this material that modern building science is only now measuring, and that modern building codes still refuse to acknowledge. Professor Mike Lawrence spent 13 years trying to understand why hempcrete works better than it should. At the University of Bath and later the University of Suffolk, Lawrence ran the BRE Center for Innovative Construction Materials with funding exceeding £1 million. He led the EU-funded Isobio and Hempsic projects. He built test structures, the Bale House in 2009, the Hempod in 2010, and measured everything. What he measured contradicted the numbers on paper. Hempcrete's steady-state R value is only R2.0 to R2.5 per inch. That is lower than fiberglass, far below spray foam. If you looked only at R value, the number on the insulation package, the number building codes used to determine compliance, hempcrete would lose. But Lawrence's team was not measuring insulation in a laboratory. They were measuring homes. At the BRE's Haverhill housing project in the UK, hempcrete walls consistently outperformed their own lab-tested R values. Energy consumption was lower than predicted. Temperature stability was higher. The buildings were working better than the physics said they should. The answer is that R value measures only one dimension of thermal performance, resistance to heat flow under static conditions. It ignores thermal mass, the wall's ability to store heat like a battery. It ignores moisture buffering, the wall's ability to absorb and release humidity without degrading. Hempcrete does both, simultaneously, in a single pour. A Slovak study measured the thermal phase shift of hempcrete walls compared to mineral wool assemblies. The difference was more than 12 hours. Outdoor temperature peaks were delayed by half a day before reaching the interior. Your furnace fights to respond to temperature swings every few hours. A hempcrete wall smoothed those swings across half a day. The physics is different, the experience is different. Internally, you always have very steady humidity, around 50 to 55%, which is ideal for the best possible health of the occupants. Lawrence observed. The wall breathes, the wall stores, the wall regulates. Then there is fire. On February 15, 2020, Chauri Hempitecture, a company founded in Ketchum, Idaho, subjected hempcrete to ASTME 84 testing. This is the standard flame spread test used to rate building materials in the United States. The result, flame spread index of 0, smoke developed index of 0. A perfect score on a scale that goes up to 450 for a plant. Fiberglass typically scores 5 to 25. Hempcrete scored 0. But the more dramatic test came 4 years later. On July 9, 2024, Cameron McIntosh of Amershambray conducted the first full-scale ASTME 119 fire resistance test of hempcrete in the United States. A 12-inch spray-applied wall, 1700 degrees Fahrenheit on one side, 60 minutes under structural load, followed by a hose stream test. McIntosh's description: breathtaking to observe that face never rose a single degree above ambient temperature, despite the intense heat on the other side. 0 flame spread, 0 smoke, 1 hour at 1700 degrees. The mechanism: lime creates a mineral barrier while hemp chars into an insulating carbon layer that self-extinguishes. The wall does not melt, does not drip, does not release toxic gases. Then there is carbon. A. J. Earhart at the University of Colorado Boulder published in the Journal of Cleaner Production in 2020 what might be the most counterintuitive finding of all: net carbon storage of negative 16 kilograms of CO2 per square meter of wall assembly over the full life cycle, not reduced emissions, negative emissions. The wall absorbs more carbon than it took to manufacture. Hemp crops absorb 8 to 15 tons of CO2 per hectare during growth. The lime binder continues reabsorbing CO2 through carbonation for decades after installation. You pour the wall once, it sequesters carbon for a century. A wall that insulates, a wall that cannot burn, a wall that absorbs carbon from the atmosphere. Lawrence's team measured one more thing: cost. Under the EU-funded Isobio project, they tracked construction costs across multiple countries. In the UK, hempcrete walls cost 30% less per square meter than conventional walls, delivering equivalent thermal performance. In Spain, the figure was 55% less. In the United States, the same material costs $12 to $46 per square foot, a premium of 8 to 60% over conventional construction. Same material, same physics, same plant. The only difference is what each country decided to make possible. Lawrence put it simply: if you put a blowtorch onto a building of hemp lime, after 2 hours it wouldn't catch fire. The physics has been measured. The fire resistance has been tested. The cost advantage has been documented in multiple countries. So why does hempcrete cost more in America than anywhere else on Earth? The answer begins with 3 laws. The Marijuana Tax Act of 1937 was championed by Harry J. Anslinger, Commissioner of the Federal Bureau of Narcotics. The act imposed a $1 per ounce tax on cannabis and created registration requirements so burdensome that hemp cultivation became economically unviable overnight. Anslinger strategically used the Spanish-Mexican slang term marijuana, unfamiliar to most Americans, to associate the plant with immigrant communities and stoke racial prejudice. William Randolph Hearst amplified the campaign through his newspaper chain. The DuPont family, which had patented nylon between 1935 and 1938 and a new wood pulp paper making process in 1937, stood to benefit from hemp's elimination as a fiber competitor. The degree of corporate orchestration remains debated among historians. DuPont has always disputed direct involvement, but the effect of the act is not disputed by anyone. The last commercial hemp fields in America were planted in Wisconsin in 1957. Then came the Controlled Substances Act of 1970. This law classified all cannabis sativa, every variety, every cultivar, every use, as Schedule I. The same category as heroin, no distinction between hemp, which cannot get you high, and marijuana, which can. A farmer who wanted to grow hemp after 1970 had to register with the DEA. The process required FBI background checks, 24-hour monitored security fencing, documentation so extensive that, according to Kentucky Hempsters, only one grower in United States history successfully registered during the entire 48-year prohibition period. One person, 48 years. The 2018 Farm Bill ended the federal prohibition. Signed by President Trump on December 20, 2018, the bill defined hemp as cannabis sativa with less than 0.3% THC and removed it from Schedule I. Senator Mitch McConnell was the driving force. He signed the legislation with a hemp pen. But legalization did not mean access. The legal wall had fallen. The code wall remained. Picture yourself as a homeowner in 2015. You have read about hempcrete. You understand the physics. You want to build with it. You cannot legally grow the primary ingredient. That is still a federal crime. You cannot import it without navigating customs agents trained to treat cannabis as contraband. You cannot find a contractor because no one has ever built with it. You cannot get a building permit because no code mentions the material. You cannot get a conventional mortgage because appraisers have no comparable sales. You cannot get standard homeowners insurance because insurers classify it as non-standard construction. Every door is closed. Not one of them closed because the material doesn't work. Even after the 2018 Farm Bill, hempcrete faced a building code system designed around manufactured products with corporate sponsors. Before the 2024 IRC Appendix BL, every hempcrete project required approval as an alternative material and method, a variance process that added $60 or more per square foot to construction costs. The Hemp Industries Association estimated that the total premium could reach $100,000 depending on home size. The U.S. Hemp Building Association raised over $50,000 and invested hundreds of volunteer hours to submit hempcrete for the 2024 International Residential Code. The code submission was co-authored by architect Martin Hammer, structural engineer Anthony Dente of Verdant Structural Engineers in Berkeley, and architect Anna Konopitskaya of Coexist Build in Pennsylvania. 3 people, $50,000, against an industry with billions. And even after inclusion, Appendix BL is voluntary. States and local jurisdictions, thousands of building departments across the country, must individually adopt it. Hempcrete remains entirely absent from the International Building Code, which governs all commercial construction. They wrote a tax act in 1937 that collapsed the American hemp industry within 20 years. They classified a building material alongside heroin in 1970 because they could not distinguish between a plant that insulates walls and a plant that alters consciousness. They built an appraisal system that cannot value a home without comparable sales, and then ensured there would be no comparable sales for 81 years. They created an insurance industry that classifies non-standard construction as high risk, and then made standard construction the only legal option. They wrote building codes updated every 3 years by committees populated with HVAC contractors and insulation manufacturers, and wondered why materials that eliminate HVAC dependency never appear in those codes. They did not conspire in secret meetings. They simply built systems that reward recurring revenue and exclude everything else. The global fiberglass insulation market was valued at approximately $10.2 billion in 2024, projected to reach $12.4 billion by 2030. The industry is dominated by Owens Corning, Johns Manville, a subsidiary of Berkshire Hathaway, Saint-Gobain, and Knauf Insulation. These corporations have decades of code integration, established distribution networks, and deep institutional relationships with the committees that write the rules. No evidence was found of direct lobbying against hempcrete by these companies. None was needed. The structural advantage of incumbent industries in code making is self-perpetuating. The system does not need villains, it only needs inertia. But the 81-year gap is over. Hemp is legal. The code appendix exists, and across the country, people are building anyway. The first hempcrete house in America was built before hemp was legal to grow here. The iPush House in Asheville, North Carolina, was designed by Anthony Brenner of Push Design for former Mayor Russ Martin. Completed in August 2010, the 3,400 square foot home used 12-inch hempcrete walls with Tradical hempcrete imported from England because growing the primary ingredient in the United States was still a federal crime. Total cost $452,200, $133 per square foot. The shell went up in 2.5 weeks. The outcome told the story the building codes could not. Martin reported a 60% reduction in his homeowner's insurance premium. When he sold the home in 2017, the price was $685,000, a $230,000 profit, on a material that appraisers said had no market value. The walls will outlast the mortgage by 500 years. The builders who followed did not wait for permission. Matty Mead founded Hempitecture in 2013 as his college thesis at Hobart and William Smith College in Geneva, New York. The company now operates a 33,000 square foot manufacturing facility in Jerome, Idaho, producing hemp wool insulation at R3.7 per inch and proprietary hempcrete binder. Both founders made Forbes 30 Under 30 in 2020. Americhanvre in Pennsylvania sprayed 4,000 cubic feet of hempcrete in 15 days for a 2-story home in Rochester, Minnesota in 2025. The company received a $1.9 million U.S. Army SBIR grant for hempcrete development. Matt Marino of Homeland Hempcrete in North Dakota manufactures prefabricated hempcrete panels that install in 1 to 2 days with zero on-site curing. The wall arrives finished. You bolt it together. But the most significant story is happening in Morton, Minnesota. The Lower Sioux Indian community began growing hemp and building hempcrete homes in 2016, 2 years before the federal ban was lifted. Project manager Danny Desjardins has overseen what became the largest hempcrete production facility in the United States, a $6.2 million, 20,000 square foot operation that opened in April 2024. The cost breakthrough is the headline. Some buildings constructed by the Lower Sioux community cost 20% less than conventional construction. Not 20% more, less. They achieved what 81 years of prohibition prevented: a local supply chain, local hemp grown in Minnesota fields, local processing at their own facility, local labor from the community, local walls in homes that will still be standing when everything we call modern is archaeology. Minnesota Lieutenant Governor Edaste Peggy Flanagan called it a great example of a housing project driven by the community. Plans are now in place for dozens of additional homes and 30 rehabilitations funded by an EPA grant. Oregon State University's Global Hemp Innovation Center received a $10 million grant to work with 13 indigenous tribes on hemp innovations. Texas A&M received $3.8 million from the Department of Energy for 3D printed hempcrete housing research. The international comparison makes the American delay inexcusable. France never banned hemp. Its National Federation of Hemp Producers dates to 1932, 5 years before the Marijuana Tax Act made American hemp cultivation a crime. In June 2024, France expanded its hempcrete building code to permit construction up to 8 stories, 28 meters. Hempcrete has been classified as a technique courant, standard practice, C, since 2015, qualifying for this country's mandatory 10-year construction warranty. Belgium's Isohemp invested 5.9 million euros in a factory capable of producing 5 million hemp blocks per year, enough for 1,800 carbon-neutral homes annually. Same material, same physics, different policy, different outcome. Hempcrete is not an anomaly. The same pattern, ancient technique, proven performance, no corporate champion, code exclusion repeats across natural building. Straw bale construction delivers R26 to R33 for a standard 23-inch wall. It was excluded from all national building codes for over a century until the 2015 IRC Appendix S. Cobb Building has more than 20,000 homes still standing in Devon, England, many built in the 1400s, 600 years old and still inhabited. There was no U.S. building code for Cobb until 2020, yet passive solar design was proven by a Department of Energy field program to cut building energy needs in half, at no more than a 10% cost premium. From 1978 to 1981, passive solar home construction grew 80-fold. Then the Reagan administration gutted solar funding and removed the panels from the White House roof. Earth tubes deliver 24 to 38% yearly energy savings by leveraging the Earth's stable underground temperature. No U.S. residential building code mentions them. The U.S. HVAC industry exceeds $130 billion annually. The code submissions for straw bale, cob, and hempcrete were all navigated by the same 3 people: architect Martin Hammer, engineer Anthony Denta, and code consultant David Eisenberg. An entire category of building materials depended on 3 individuals fighting a code system backed by billions in incumbent industry revenue. The physics has not changed, the archaeology has not changed, the fire tests have not changed. What changed is that you now know. They will not tell you that a wall tested at 1700 degrees for 60 minutes never rose a single degree on the unexposed side. They will not tell you that hemp lime plaster has been found intact in 1,500-year-old temples, still insulating, still regulating temperature, while the fiberglass in your walls will need replacing before your children inherit the house. They will not tell you that the same material costs 55% less than conventional construction in Spain and 30% less in the UK, and that the American premium exists not because of physics, but because of 81 years of policy. They will not tell you that the code submissions for every natural building material in America, straw bale, cob, hempcrete, were written by the same 3 volunteers, working with donations and weekends, against industries that spend more on trade show booths than those advocates raised in a decade, a plant that scores 0 on flame spread tests, a wall that lasts 1,500 years, a material that costs less than what it replaces everywhere except the country that banned it for 8 decades. The prohibition is over. The code appendix exists. The supply chain is emerging. The hemp is waiting in fields across Montana and Idaho and Minnesota, in processing facilities built by indigenous communities reclaiming agricultural sovereignty, in walls going up right now, in houses that will still be standing when everything we call modern is archaeology, a wall you pour once, a material that sequesters carbon instead of emitting it, insulation that does not require a respirator to install or a landfill to dispose of. This is what 81 years of prohibition tried to bury. Every share builds what they tried to bury. Every viewer who learns this becomes someone the system cannot easily mislead. The information exists now. It cannot be unlearned. Next time on Forbidden Homestead, there is a wall system that heats your home using nothing but sunlight and thermal mass. No furnace, no ducts, no monthly bill. It was standard practice in the American Southwest for 1,000 years. Then building codes arrived, Trom walls. The archive